Double check that we're not muted.
We're good.
Okay. All right.
Welcome to the City of Long Beach Development Services Community Training. Thank you for staying with us if you were here for the first session, and thank you to those joining us now for our second session on methane gas mitigation, an overview of the requirements under recently enacted Long Beach Municipal Code 18.79. Here again is our main presenter, the city's Superintendent of Building and Safety, David Coran.
Thank you, Rick, and thank you to our technology and innovation staff and also our communication staff to make this public presentation possible. We have an hour-and-a-half presentation on methane gas mitigation, the lately adopted ordinance Long Beach Municipal Code 1879 for you. This presentation is full of the videos, with pictures of the latest projects that we have experienced in Long Beach in order to make it exciting for you to sit and stay with us for an hour and a half. Before going further in detail, my name is David Coran. I'm Superintendent of Building and Safety, a building official for project in Long Beach. And also, whenever the development happens on private property is under my jurisdiction. So mitigation of the, for methane gas conversation that we have with you relates to just work in private property and not public works or public property. With me today, I want my colleagues to also introduce themselves.
Good morning, everyone. My name is Jenna Oshia. I am a business systems specialist over at City of Long Beach Technology and Innovations Department's GIS team.
And good morning, everyone. My name is Ezekiel Rincon Hernandez, Combination Building Inspector for the City of Long Beach.
Thank you, Jenna, and thank you, Ezekiel, for accepting to be a part of this presentation and assist us in delivering this message to our audience here. I don't know if it's possible. We have 21 or 29 people attending this meeting. I'd like to take a short meeting and give you the opportunity to introduce yourself, if it's possible. If you hear me, please activate your, unmute yourself and introduce yourself.
Well, I hope you can hear me. Bożena Jaworski, architect for RPP Architects, and I work on several properties in Signal Hill and some in Long Beach that are located on the oil fields. So methane is the first consideration, and I really appreciate your efforts to put together the oil wells and methane mitigation seminar. Thank you so much.
You're welcome. Next.
My name is Carlos Zavalla. I'm an architect here in Long Beach. I've worked in projects involving methane ever since the 1985 explosion over in oh my God, at the Ross store in gosh, I forget the neighborhood, but he's on 4th and Fairfax. That used to be my neighborhood, and I was there when that explosion happened. So ever since then, I've worked on projects involving the early stages of methane rules that were implemented by the city of LA in the old LA oil fields, and many more since then. Thank you.
Next person.
This is Val Lerma. I'm not sure what order we're going in, but I'm happy to introduce myself. I'm with Interact. We're an oil and gas consulting firm located in Ventura, and we have clients anywhere from Santa Maria to Bakersfield to the LA Basin. I started my career with Chevron back in the early 80s, working on drilling rigs. My expertise is all downhole. I've since gotten involved in quite a few development projects, just evaluating wells for different developers. And I've had quite a bit of experience with CalGEM, and the distinction between CalGEM and its current standards versus developers and safety for service development are quite different. So it's very refreshing to hear that Long Beach has has made some clear guidelines for developers that are independent of CalGEM's current standards. So I'm happy to be part of these discussions today.
Thank you. Next person.
My name is
You're on
Tom
mute.
Walker with Evans and Walker, and to reiterate what Val said, I've been working in the LA Basin for about 30 years. Did my first abandonment work in the 1990s, and served as a consultant for oil and gas companies and developers and cities. Do valuation work and a lot of downhole work, and thoroughly enjoyed the first half. I'm looking forward to additional information in the methane mitigation section.
Next person. I know some of you guys are still cautiously waiting online, but please project your name, voice.
This is Kevin with Geokinetics. I've been working methane and vapor plans and mitigation since back when Playa Vista started, probably 20 plus years ago. So a lot of work in LA, a lot of work in Long Beach and Southern California.
Thank you, Kevin.
Yes, hello, this is Kevin Laney with Signal Hill Petroleum. I want to thank David and his team for the presentation today, and obviously the several years of hard work putting this together. We're pretty extensively involved in the development of oil field properties and have been, for the past 30 years. But anyways, thanks very much, David, and the team for finally making all this real.
I saw Richard, I saw a few other names. Please, we want to hear from you.
Hi, good morning. This is Fabiana Arriaga. I'm with Geosyntec and have been working on the methane mitigation projects in this LA metro area for the past few years.
Okay. Jonas, anybody else who want to introduce themselves?
Hey, David, this is Matt Simon Glover Architects here in Long Beach. We're looking at a couple properties for some clients with oil wells currently, and I unfortunately had to suffer through capping 2 oil wells about 4 years ago with Dogger in the city of Carson.
I hope we can reduce your suffering here.
Yeah, it's better already.
When I hear that word from an architect, believe me, it resonates with me. So sorry if I...
It's better already, thanks.
You're welcome. We do know you're online, so please let us introduce yourself because we don't want to waste other people's time and go through the presentation. A few more minutes for you guys to introduce yourself. If no more taker here is, then this is where we go. All right, let's start with this presentation. As I said, it's going to be an hour and a half long, but looking at the clock, there is going to be plenty of time for any answering questions to answer. Please utilize our chat line to communicate, send your questions. And we have people here that they can help us with the chat, and if we can answer the questions during the chat, we will. Or otherwise, we leave them at the end to talk. The slide that you see in front of you is the introductory slide on what we're going to cover. Again, we're running a very parallel process with the methane gas mitigation. We're going to give you some introduction about gas mitigation, why it exists and how we deal with it. And Jenna is going to talk about it more extensively about the GIS layer and methane and how it came about. Methane gas mitigation, the process, the elements, the components of the methane gas mitigation will be discussed. And we will introduce these prescriptive standards that we have came up with the utilization or help of a consultant, Geosyntec, that's online today. The representatives are also listening to this. They were the consultant that they help us to develop prescriptive standards. We will explain how this all came about. We will get into the design levels that exist in methane. No two sites, when it comes to methane reading, will read the same way. So the crux of this whole concept is based on how much methane is detected on site, based on pressure and based on the volume of the methane. We will get into tables and discussions. And then we discussed about these prescriptive standards, the plan check reviews, what needs to be shown on a plan, what needs to be inspected in the field. And we really get into the passive and active systems. Based on the environment, based on the wind speed, based on location of building, based on the amount of methane, sometimes the methane can passively dissipate, and sometimes you need an active system to pull it out of the ground, or pull it out of the areas, or pull it out of the building. Methane, obviously an explosive gas, combustible gas, so very concerning to deal with. For those of you, most of you know, methane is the gas that we use sometimes, it's considered natural gas. It's the gas that we use at our homes. But the natural gas that we use at our homes comes through the pipes, comes to regulatory bodies, and systematically, safely get to our homes. But the wild methane gas that's outside, underground, not planned for, could cause a lot of problems, and has caused problems before. We all saw when city of LA streets were on fire, give and take 10 years ago, because of methane eruptions of the lakes. Then we get into at the end, we get into the responsibilities and liabilities of and the paperwork that we go through. And then we open up to the question and answer section. History of the methane gas, when we were working on developing the construction within the oil wells, as I mentioned earlier on, it dawned on us that the methane gas needs to be mitigated. It dawned on us that the city of Long Beach did not have any policies or ordinances, and we relied on other agencies like LA County or City of LA, more progressive cities that have experienced these things before. But it was very timely for us to develop our own methane standards and bring it in while we were bringing in the oil well standards and make sure they collaborate, they work with each other in tandem and they're not off. So timing was very legit, very valid to do both at the same time. There was also economy of scale dealing with the consultants to develop these two standards and consult, and also economy of scale when it came to staff time and developing it, rather than independently or separately developing it at different time. When that decision was made by the city management and city managers, we hired, as I said, a firm called GeoCentec, a local firm with that kind of experience. We looked at several cities in Southern California, in Orange County, LA County, with the similar programs and similar ordinances. All that information was pulled in a very large matrix, evaluated, simplified, or even in some areas become more restrictive when it was necessary based on experience that we got. We actually visited a couple of agencies and talked to their officials about how they deal with the oil wells and how they deal with methane. And at the end, this whole thing came about as an ordinance, 18.79. It's an extremely technical, I would refer to it more technical than oil well ordinance. And for those of you who are into writing ordinances, the technical part of ordinances normally separate and they manifest themselves in an informational bulletin type. So the information bulletin and the Long Beach Municipal Code, they work in tandem with each other, in support of each other. What you see in front of you is a 45-page information bulletin. As I said, methane mitigation is very technical and talk about different stages, post-construction, during construction, pre-construction. But the table that you see in front of you is the key to the understanding of the methane mitigation. As I earlier on mentioned, this table on top shows 3 levels of the methane, and each level is based on the water column, based on the pressure that methane gas is detected on the site, plus the volume, ppmv, part per million of the methane. This is how a gas is measured. How fast it's coming out of the ground and what density it comes out of the ground. Based on those parameters, the 3 levels were identified. And if you look at the extreme left column, there are give and take 12 mitigation steps that are involved, from the gas membrane barrier installation, perforated horizontal pipe that needs to be installed, eventual vent risers that go up the building to get rid of the methane gas detection system inside the building, inside this riser, inside these pipes. We get to the alarm system that might be necessary, control panel, mechanical ventilation, because some of these fumes can get into the mechanical system, or you need a mechanical system to push it out. Pavement marking, and a few other things. As you can see, we will get into this table a little bit more later on, but there are X's in this table that identify what the designers or engineers need to use. And the reason we call it prescriptive, because it's all spelled out here. If a consultant takes this, or a design team, an architect, take this ordinance or this bulletin to heart and learn it, they can actually put enough notes on their plans and address any methane situation that may run into based on the methane reading and measurements. This bulletin also gets into, as we scroll down, on how to do testing. What are the requirements for testing? When the mechanical ventilation requirement comes. It's pretty expensive. And it also gets into the electrical side, class 1, division 1, class 2, division 1 and 2, electrical, for electron installation in proximity to methane gas. We all know methane gas is combustible and doesn't do very good with the arcs and faults and electricity. Then we get into operation manual that needs to be delivered, and I'd like to emphasize here, later on in this presentation, I'm going to ask Jenna to go through this methane gas mitigation zone in detail. But as you can see, and as she will explain, there's a good part of Long Beach now is considered in the pink zone, and that's the methane area. So it's going to encompass large area, large number of projects, with the caveats, of course, and exclusion and exemptions that we will get to that presentation discussions today. One important thing about this prescriptive standard, there are 21 standard details that, from how to put a barrier on the ground, how to protect how to run the barrier on the building footing, how to start vents, how the vent come off the ground, how the alarm gets installed. If you can scroll through them, you will see how the vertical risers need to be sealed up for the leak gas not to go through wrong places. Then it comes to electricity, vertical riser for the methane, slab venting system, the control panels or any associated signage and electrical requirements, the wall system, because gas can trap underground in the wall system, detailing, how you poke the buildings, how you poke the footing, the cap or ventilation system on top for the passive system. All these prescriptive details that could apply to the job, for most part, has been evaluated by our consultant and manifests itself on this bulletin. At the end, certificate of compliance and the paperwork associated and the document that needs to be recorded is all also part of this bulletin. So if you take this bulletin, study it, it will give you A to Z, as they say, soup to nuts on methane mitigation in Long Beach. Very good. Why now we are almost at the last bullet point of large areas in the city was identified to be a methane zone. However, there are very large exemptions, so we don't jeopardize projects, small projects. The methane mitigation is basically geared towards large buildings, large projects. So anything with 50% of existing structure improvement does not get triggered. In other words, if you have a shopping center, if you have a hotel, if you have a residence, you want to make 50% improvement. Below 50% improvement, this ordinance does not apply, and you can proceed. But if you're doing brand new buildings, if you're doing substantial improvements in large enlargements, then the methane standards become applicable. Certain projects, like open parking structures, projects that they can ventilate themselves and fume doesn't get trapped, they're also excluded. But all this gets established with site testing. So if you have, let's say, a room, you want to do a 5,000 square foot home, and you do your testing, and testing shows no methane in your site, even though it's identified in our methane zone, you're excluded, but you need to substantiate and bring that document forward. Moving to the next slide. At this juncture, I'd like to leave it to Zeke to share with us some of his field experiences with methane mitigation.
Thank you, David. So this two pictures show the basics of the membrane. What we're seeing as the dark area. Excuse us for having some audio difficulties right now. Okay, so thank you for your patience and understanding. So this project, I just like to show you how the methane membrane looks like, and that is the black dark area, and right after the spray applied asphalt membrane is tested, smoke tested, it must be protected. So in this picture, I'm showing the membrane, asphalt membrane, and also the protection layer, which is a whitish layer. Now, the designer plays a role in what type of system it's more appropriate for the project. So the protection cover may be a different materials. It happens to be it's kind of a tarp looking material when you see it, and it'll protect the membrane again from any punctures from sharp objects or walking on it, and after the membrane is protected, it should be ready for rebar. But I'd like to show you also on the picture on the right where the metal structure is at. It shows another type of material that is protecting it. It looks like the T40 or let me see, it's a T40 or T60 or temp-proof protection layer. But what is important when putting all these protection layers is also to attach it to the membrane so it's not moved or moved away unintentionally. And once that is done, the laps where the membrane protection layer is lapping, it should be also attached or to the membrane itself. Excuse me for stuttering. Any joints lengthwise should be sealed, and any joints at the end should be also staggered. So there is a procedure of installation, and the membrane when it's extended to a footing, it should be also concrete footing should be attached either to the footing or if there's a vertical wall, the designer will have to determine how it's going to be terminated. And that's basically what these pictures show. So we'll be seeing more pictures as we move on in the training. Okay, so this picture again, it's the laser pitch project. And during the methane mitigation system installation, a few inspection, let's call it not problems, but hurdles we had to go through due to the design of the building and progress of the building. Some of the inspections were not conducted during the methane mitigation installation components installation. Unfortunately, if any components are not inspected or observed by the city representative, the contractor or owner of the project has a responsibility to make those areas accessible for inspection, and that's what happened at the laser pitch. Unfortunately, just a few areas had to be uncovered to inspect any components above ground level, vertical risers, and vertical risers basically, which must be inspected for signage to identify the type of venting the pipes are for. So the signage had to be inspected, also the anchorage to the building on vertical position or horizontal position and terminated outside of the building. And we are seeing at the back of the building, there's another open garage parking structure that did not require per city ordinance does not require the methane mitigation system. However, the owner decided to install it for some reason, and we are pleased with that. So both of those structures are sitting on a methane mitigation barrier. From here, David, I'd like to move to the next slide and
Thank you,
take it from here.
Methane zone mitigation that very shortly Jenna will go through in details and show you the actual maps, came about based on identifying several areas that are highlighted as a bullet point here. The city considered all areas overlaying petroleum-bearing formations and within the limits of the reservoir boundaries that existed on CalGEM maps. That information was brought in. We looked at proposed development of structures within 300 feet of any active well and any 100 feet of an idle wells. That information was brought in. Next slide. We also looked at proximity of the landfills, the couple landfills in Long Beach. Anything within 1,000 feet of landfills, because landfills also create methane or produce methane. So that those zones were all depicted on GIS system and they were mapped. We also looked at the coastal zone projects and properties that will be in coastal zone. They still have to go to the coastal zone requirements and review. And those are not excluded. When a whole map came about, then the development coordinator, which happens to be again my office, has also an ability to select another area that we may find out in future that produces methane. With all these rigorous areas that we zone, and we came up with a methane zone, we cannot deny that there may be another area that becomes effective 5 years down the line, 10 years down the line, for different reasons. So that is also some bullet point that we are thinking. And with all that in mind, when we go to the next slide, I'd like Jenna to take it from here and show us your hard way to work.
Thank you, David. All right, so if you could go back to the PowerPoint, please. So I'll be going over the web application where you can search for a location to see if it's within the methane gas mitigation zone or outside of it. As you can see, this is the link to the web application. You can also find the same link within the bulletin. For those of you who are here in the first session, this is the same link to the application that I just went over. And for those of you who missed the first session, I'll also show you how you can access the web application through the city's website. So could you please go to the city website? Thank you. The city website is www.longbeach.gov. When you're in the home page, on the right side, there's different tabs. Third from the bottom, you want to click on the planning and building. What it'll do is it'll direct you to the development services page. At the top right, there's the maps section. Hover over the maps, and you'll find the methane gas zone GIS map. Once you click on it, what it'll do is it'll open up a new tab, and it'll direct you to the web application. The first thing that you're going to be seeing is the disclaimer. The disclaimer is regarding about the data that is being used within the application and also the terms and conditions. So you'll need to read the disclaimer, click on I agree to the above terms and condition, and press OK. Once you do that, you have access to the app. The majority of the screen is the interactive map. On the left panels, there's different widgets which will help you understand what these layers of symbology means, and also search functionality as well too, where you can search for a location that you're interested in. Top left, this is the Methane Gas Mitigation and Oil Well app, the title. Top right, this is the link where once you click on it, it'll open up a new tab and direct you to the schedule building inspection page. Going back to the application, I'm going to start off with help you understand how to navigate around the interactive map. Top left, this is the plus sign where once you click on it, you zoom in the map. Opposite to that minus sign, you zoom out. If you want to pan around, just click and drag around the map. You can actually do the same thing with your mouse scroll as well too. So hover over the location that you want to zoom in and scroll in to zoom in, scroll out to zoom out. If you want to go to the default extent of when the application opened, you'll want to click on this home button, the default extent, and it'll go right back to the whole city boundary. This button is my location. If you have your GPS enabled on your device, what it'll do is it'll zoom you right to your location on the map. So again, plus to zoom in, minus to zoom out. And if you want to go to the default extent, just click on the home button. On the left panel, the default widget that's turned on is check locations. This is where you can search for a location. So what I'm going to do is I'm going to put in an address, 411 West Ocean. You can click enter or search. And, oh, there's connection issues. All right, Keishan, could you go ahead and press West Ocean, please? Thank you. And then I'm going to click search. And what it will do is it'll zoom in right to the address, and it will also select the parcel that it intersects with the address. On the left side, you'll also see additional information regarding the parcel, and you can actually see the same information if you click on it as well too. This URL more info, once you click on it, what it will do is it will open up a new tab. It will direct you to the LA County's Assessor portal page so you can see additional information regarding the parcel. I'm going to exit out of here, and going back to clear selection, all you have to do is click on the X to clear search. This button is very similar to the My Location that I just talked about. It will zoom you right to your location on the map. You can also click on this set location, click on a point on the map, and it'll show you the address and also the parcel that gets selected and the additional information. Other than address, you can actually search by APN as well too. So if you know the parcel's APN, go ahead and type it into the search. If it's in the Long Beach database, it'll also show up within the dropdown, so you can actually just click on it It will zoom you right to the parcel and select the feature just like the address. And lastly, you can also search by coordinates. So let's see if my keyboard works. Oh, it does. So let me type in the XY coordinate. And click search. Same thing as the past two. It'll zoom right to the latitude and longitude that you just typed in and select the parcel. If the parcel that you're searching for has this red pinkish overlay, that means it's within the methane gas mitigation zone. So as you can see, the red area, the pink area right here, is the methane gas mitigation zone. Outside of it is outside of the zone. Now I'm going to start talking about the widgets from left to right. Let me go ahead and click that. This is the About widget, and it tells you the description of all these icons. At the very bottom, this is a disclaimer. This is the same disclaimer that you saw when you opened the web app. Second widget is the check locations that we just went over. This is the legend to help you understand what these symbols mean. So again, this pinkish layer is the methane gas mitigation zone. The black outline is the city boundary. I'm going to zoom in so the other layers will be turned on. The green dot you see here, this is the active wells, and you can see the 300 buffer around it. If I navigate over here, the gray point is the inactive wells with the 100-foot buffer. These active and inactive wells are data from CalGIM. And this is the black square is Swiss site, so Solid Waste Information System site, and this is from CalRecycle, and there's a 1,000-foot buffer around it as well too. The methane gas mitigation zone layer will be updated twice a year around January and July based on the new data that we receive from CalGIM and CalRecycle. As you zoom in, you'll also see the gray line. This is the parcel. So the sister parcel will be updated on a monthly basis. The city does receive updated parcel information from LA County. The fourth widget is the layer list. You can actually turn on and off the layers. By default, there are certain layers that's already turned on, and we also have additional layers for your reference. So let me go ahead and turn off the default layers. And I'm going to zoom in a little bit more. The CalGIM wells. So these are well data directly being pulled from CalGIM, which has the same legend, the same symbology, the same description. You can additionally click on the well to see additional data offered from CalGIM. And we also have oil area, oil sub area. This is a layer used internally for the city staff, but we also have it available for your reference if you'd like to use it. And additionally, we have the Atlas map tiles as well too that the city used. At the very bottom, you'll see the oil gas field. Again, this data is from CalGIM. You'll see the oil gas field boundary around the city of Long Beach. If you click on the layer, you'll be able to see the name of the oil gas field. And lastly, we have the base PLSS. If I click on it, you'll see the township range. And you'll also see the section as well too if you want to use it as a reference. So for the layer list, you have control over what layers that you want to make it visible on the map and which layers that you want to turn off. And I'm going to zoom into a little area again. Lastly, we have the base map gallery where you can actually change the background of the map. You can change it to the dark gray canvas. You can change it to imagery. And if you like the default background that we have, just scroll all the way to the bottom and click on the web map right here on the topographic. And you're back at the default. So that was a quick overview and going over the functionality of the well application. So we're gonna go back to the PowerPoint and we're gonna transition back to David where he will be talking about more about the next slide.
Thank you, Jenna. The utilization of the methane gas mitigation map and GIS system was an innovative way for us to deal with the information. And I want to mention one more thing. The fact that we combined the two ordinances timing and we brought the oil well and methane ordinances and bulletins together also assisted us in determining why the GIS layers have to be combined in one layer. We noticed this GIS layer is, we call it methane gas mitigation and also oil well, because it contains both sets of information. It's a very, very valid document to use for especially architect developers, prospective property owners to investigate and get the information they need related to both topics. Now, moving to the next slide, we're going to get on the technical side of our presentation, but intentionally we're going to utilize the very simple language to explain all these things you need. But if I'm a designer or an engineer looking at the site and I want to see what the city is providing me as a part of the prescription, as a part of prescriptive method that I can put to the job and save a lot of money, this is what I do. This is what I need to understand. All information you need about the gas membrane that Zeke was explaining or talking to us, and also you're going to see on some more videos from us coming up. It's all in there. The thickness, the material, where it has to be laid, how it needs to be installed, the gravel below, sand above, all that sandwich, all that structure you need to protect the pipes are there. Underneath that system, obviously, we run the horizontal pipes, which are perforated. And you all know when it's a perforated pipe underground, it can get full of water. So you got full of water in the perforated pipes, plus potential some methane, all mixed in there. But it's all allowed, as long as the wind goes up and the gas will find its way to get out of the pipe that could have water in it. But that's all actually accepted. That is called sub-slab ventilation. Then we get above slab ventilation, the pipes and controls and measurement devices that go to the pipes as we measure how much gas or methane is being emitted. Then we talk about shutter valves for sampling ports that will get installed in the vertical risers. We talked about the methane gas detection and alarm system for level 2 and level 3, which I will go in more details of those. Then the process gets a little bit more involved because then you have mechanical ventilation and mechanical plant checkers and engineers get involved with active versus passive systems. And then we get into some more specific utility and trench dam, and the signage is very quite important. This table that we have it here was copied from the bulletin and also from the ordinance. I explained the top row and the extreme left row. But let's go and get into the X's and see what it takes. If we detect level 1 pressures on the site based on the low probe testing and a deep probe testing, all we need is a metal barrier and the pipes and some signage and some trench dam details. But as we move to the level 2 is tricky because we are talking about pressures and we are talking about different kind of volume of the methane gas. You will see more X's appearing in those columns, and those X's starts talking about gas detection, alarm system, control panels, low voltage system. As soon as we get into the alarm system, we are talking about the backup generator and backup powers in the buildings. Because if the city power is out, this alarm system, these generators, these systems that they have to come on won't work. So more cost, more consideration as we move to level 2. But we still at the level we call it passive. We get to the last level, you see there is one more X get added to the last column, and when you come across, we call it mechanical ventilation. That's where, or mechanical subslab extraction, sorry. That one is the one that, besides building air conditioning system, besides regular air in a building, you need extra power or extra mechanical system to take the gas that created a lot of gas and emit it out of building. So that adds a lot of cost to the project, but that's what we refer to an active system versus level 1 and 2 are still passive. We will get more into details of these, but if you need to read about these items one by one, the sections of the ordinance and the bulletin are spelled out in front of each item. And as you become familiar with our online bulletin and ordinance, you can read on all of these topics directly based on the sections that are indicated on this presentation, on this table. Next slide, please. Now, the equivalency standard administration, or this system that we have there, I should call it prescriptive standard, is goes to the plan check with the city plan check and inspection staff will inspect it. City development coordinator or building official, by now, you know my office role and what I do when it comes to considering prescriptive application, or when we consider the code modification or deviations from the standard that we are proposing. The role of a qualified professional engineer is the same. An expert hired by the developer needs to evaluate all this and propose the methane mitigation. However, for methane mitigation, the credentials are different. Here, the individual can be a California registered professional civil engineer, can be a petroleum engineer, or could be a geologist hired by the developer. Versus with the oil well was restricted petroleum engineer. There may be a need for deputy inspector to stay on the job if the qualified professional engineer cannot stay on the job, for them to continuously inspect the methane mitigation design elements and components. Going to the next slide. At this junction, I'd like to also pass it to Zeke to share with us his valuable experience in the field with these projects.
Okay, so once the mitigating system is approved and inspections are conducted, based on Chapter 17 of the California Building Code, this type of systems fall in the category of special systems that require the special inspections and tests. So at the site, I asked who is the qualified professional representative that will be observing the installation of all mitigation components as prescribed and required by Chapter 18.79. I'll be checking and contacting and talking to either deputy methane deputy inspector or to the qualified professional if he or she will be on site for the inspection of all components. With that, the pictures that we are seeing show the underground, or what David referred to as sub-slab venting piping. The city requirement requires a trench of 12-inch wide by 12-inch deep minimum for the placement of the underground venting system. And what we're seeing in these pictures, where the construction installer is holding the elbow, there is a pipe with a greenish line on top of it. So that is the perforated pipe, and before it it transitions to a vertical position out of the ground, it should be connected with approved fittings from, which is a perforated pipe identified as ADS. There should be connected to the cast iron portion that will be rising above the ground, and those connections should be observed by the deputy inspector as well as by the city inspector to make sure that the fittings and piping complies with the design by the qualified professional. And I like just to point out the elbows assembly. Is normally to see that the elbows don't take off on a 90-degree angle. Usually it is designed as for 45-degree elbows, and from the elbow that is above grading or above the concrete slab, the vertical riser will take off all the way up to its termination. Now, the pipe or venting pipe should be surrounded. The city requires a minimum drop of 4-inch of crush rack in order to mitigate or for proper transmission of the gases into the pipe and to travel all the way up to the termination of it. Now, the black material that we're seeing is a drainage fabric that will be also dropping up after the crush rock surrounds the pipe. At this point, we're ready to install either a protection layer of 2-inch sand layer, or it could be also for some projects, if designed by the qualified professional, a layer of same type of rock, 3/4 inch crushed rock. Okay, now I'd like to move from here to the next slide, please. Okay, now this side is showing a few items or components of the methane mitigation system. I'd like to start with describing the portion of the picture on the left, where the rebars are sticking up or stubbing out with those protection caps. Methane mitigation membranes may be manufactured by different fabricators or manufacturers, and each manufacturer dictates or provides the installation instructions. Not all of them use the same type of materials or combined materials, so at the inspection phase, general notes on the plans, on the methane mitigation plans, will specify what is designed for that type of a structure, and the inspector will follow those general notes as well as any details. What is common to see when the membrane, which is the spray applied membrane, what is common to see is the material, which is a liquid asphalt. A liquid asphalt that must be sprayed considering temperature, considering also the materials, the pressure on the materials is sprayed on. if the temperature does not allowed, the manufacturer should be contacted. And what I'd like to mention about this project is that they are spraying liquid boot. Liquid boot is of an asphalt material made by Sevco. There is another company, Fremco, which manufactures a similar type of material, asphalt. They call it tough and dry. Okay, so now determining which material and what specifications the manufacturer requires for the installation, that's what at the field I check. They have the proper materials, and in the picture where the metal structure is behind the column on the right, there are some green barrels. So those barrels identify the type of material, and for liquid boot, there should be two type of components: component A, component B. When mixing together, when mixing together, they form what is called the membrane, and it must cure in a certain with a minimum certain period of time. The gentleman holding the wand is spraying those two components, A and B. And notice that the wand is within the tip of the wand, which is a dual nozzle wand. It's within 24 to 18 inches from the surface. So that is required in order to apply the asphalt membrane on the base fabric, and it would allow it to mix, and also once it gets on the base membrane, it will harden. If the instructions are not followed, or the deputy inspector is not there, so then we're not achieving the design or required design. Once the membrane or the asphalt membrane is sprayed on, it must cure overnight, at least overnight, to be tested. The following day could be tested, and it should be tested under pressure with smoke. So we're gonna see a video after we see the video of this gentleman spraying the base, the asphalt on the base fabric. Now you notice it maintains a clearance of 2 feet with an 18 inches to 2 feet off the membrane. Now, interesting to know also, the pressure on each nozzle of the wand is different. One may be 60 for compound A and 50 for compound B. So all those details must be paid attention during the inspection, which is required for the installation of this membrane. With that, I'd like to move to the following slide. And in this picture, we're seeing those components. We're seeing the liquid asphalt, and on the left side we see a catalyst, which is a compound, it's a water-based compound of calcium chloride that will be sprayed through the double nozzle wand. And again, temperature should be considered. Now, there are different types of asphalt membranes. Liquid boot may be applied on horizontal surfaces and vertical surfaces. Now there's another compound, asphalt compound, which is identified as liquid wood LT, and I'm just giving you one example. Liquid wood LT is for low temperatures, so the product must be applied when the temperature is no lower than 25 degrees. There's asphalt or liquid wood 500. The liquid wood 500, if no one is paying attention or not reading the labels, this liquid wood 500 is only approved for horizontal application, not vertical. So that's what basically I go through during the application of the asphalt on the membrane. And after the membrane is cured, a request for a smoke test shall be requested to the city. And I'd like to move to the next slide. Okay. During the inspection of the smoke test or observation of the smoke test, the inspector will also verify that or will ask if the deputy inspector is on site, since the city inspector or representative is just there to observe the performance of this test. Who is responsible for approving the installation and the smoke test inspection falls under the authority of the qualified professional. So the qualified professional, if there, will make the observation. If not, the deputy inspector. And we're gonna play a small video just to show how this blower is inserting air under the membrane. You know, once air is pumped under the membrane will rise up, and if there's any leaks, it will show the smoke coming out of it. And at that point, the asphalt applicator or liquid wood applicator or membrane applicator will go and patch it. And if it's done within the same day, the inspection, it's okay to pass. We don't have to wait for the following day to cure as per the manufacturer authorization. Now, after the smoke test is performed, the contractor is allowed to install the rebar, but prior to the installation of the rebar, if there's any rebar, the membrane must be protected, and that's why the picture on the right shows 3 different layers. Again, the design will dictate what kind of a protection layer the designer prefers for this system. I like to direct your attention to the greenish area. That greenish area, it's a highly density polyethylene or polypropylene layer. Initially, for this project, that was the base material where the asphalt, liquid asphalt or methane membrane was sprayed on. Now the picture with the dark color, that shows the membrane. So after spraying the membrane and acquiring a 60 mil thickness and passing the smoke test, it gets protected. It gets protected either with a 2-inch layer of sand or any other material. And what we're seeing on the area where the welded wire mesh is at, we're seeing a G1000. It's a fabric that will protect the membrane from any punctures or from any damage. And at that point, the area is ready for concrete rebar or for any other type of reinforcing material. I'd like you to consider when designing any methane mitigation system, what type of materials will be installed, and also having a pre-con meeting prior to the installation of all methane mitigation components. Before the final inspection is conducted, the qualified professional will have to certify the installation of all the components. So understanding that the deputy inspector, city inspector, or this qualified professional will be observing the installation of all those components, prepare us for submitting all documentation and inspecting all components in a timely manner. Can we move to the next slide? You know, there are some fittings or any other components that may be interacting with a methane membrane. And for this, I'm gonna have David explain what takes place at this site.
Thank you, Zeke. Going back to the previous slide, I wanted to mention one more thing before we move to this slide. The methane mitigation plans can be submitted to City of Long Beach in conjunction with the grading plan. Another thing that we have done to make life simple in Long Beach is when a precise grading plan comes in, right before precise grading or in conjunction with a precise grading, the methane membranes can go in. So rather than separate submittal to the city, they can combine it. Developers and architect engineers can develop plans and submit at the same time, because our grading plan check engineers will check all these details. That's what it means. Moving to the next slide, in conjunction with methane, as we said, methane is a sort of an explosive and combustible gas. So anytime you work underground, above ground, in vicinity of the methane, the type of electricity or electrical work that we do completely changes. This is something that you don't see, but now because we're introducing, you don't see this very often, but because we're introducing this methane zone and has to be addressed, every electrical junction box, every conduit, every electrical system has to be per Article 500 of California Electrical Code. California Electrical Code Article 500 is about 100-page long document that provides the details for the electrical engineers to design their electrical system in proximity to the explosive condition, hazardous condition, chemicals. In our case, would be methane gas and potentially other gases that could be emitted underground. But the picture on the right shows a detail for junction box that needs to be installed on top of the methane barrier without poking the methane barrier, without making any holes. So that structure that you see, after Zeke comes through and inspects the barrier, after the barrier is pressure tested and smoke tested, the barrier is good, then the electrical trades have to start, and they have to be familiar with what they're doing. If they're not familiar with the process, they could be puncturing the methane barrier that somebody spent many years or a long time to establish. So this is a good example of a project. When this floor is all done, what you're going to see is typical concrete floor with a box, electrical boxes. But if they don't build them right, the first place that gas that you try to, the methane that the developer or designer try to mitigate will show up in a big clink with these boxes. You will start, the gas that's trapped underground is trying to escape. Rather than go through the pipe, we'll find this low weak link and will appear right here inside the building. So knowing that, throughout the life of a building, let's imagine building is built perfectly for stay, but the building, let's say a mall, let's say a shopping center, the tenants come and go all the time. The work happens in the buildings all the time. They dig to the slab. The first order of business is they dig to the slab to put a new utility. They have to know that they can dig to the slab. Or if they ever do, there's a special detailing that every architect engineer is to be aware of, because that's not a regular building to deal with the slab or the ground stuff. So having said that, electrical code and mechanical code come in big time when you deal with hazardous conditions and explosive gases such as methane. Electrical code article, the next article, I think it is 600 or 700, gets into the alarm systems. Low voltage electrical. We just talked about the high voltage or regular voltage, 120 all the way to 600 volts in buildings that could cause arc fault and fires. We have low voltage issues in buildings too, because now you're introducing methane alarm system, you're talking about horn and strobes in the buildings that all of a sudden gas appears inside the building. The methane gas, we try to make sure they don't get to the building. But what happens if they get inside the building? And it happens, and it has caused fires and problems before. All the electrical inside the building, when it becomes exposed to hazardous condition, have to be per Article 500. Accordingly, the alarm systems have to come in. These alarm systems, they go into they work based on sensors that they are installed in the risers, they're installed in mechanical equipment, installed in the lower level of the building to detect the methane, and they will send a strobe and send a blue signal throughout the floor. Some people, they mix them with the fire alarm system, but the two systems have to be independent. They are not the same systems. They may be communicating with the same control panel, but in nature they are different. Now, the fire department gets involved when we're talking about the passive system and methane alarm system approval, and these drawings come as a deferred submittal later on when we talk about passive systems. If the system is active and it has sensors, building department takes care of it. But if it's a passive system and fire department needs to get involved, according to the municipal code and according to the bulletin that we have, when applicants submit those plans, we decipher between all these things and then accordingly submit them for the right bodies at the city to review and approve these projects. So you will see that work gets really, really more complicated. Here are some examples of the seal type and explosion-proof electrical boxes and connections. Maybe next slide. Speaking of alarm sensors in the buildings, the picture on the extreme right hand shows a regular fire alarm or fire detection system that we see it normally against the ceiling of the lower level of the buildings. There is a need for the fire alarm company or methane detection company to come up with that set of plans, and their skill set comes in to install those. But the picture in the middle also shows a more advanced sensor that was installed recently in one of the buildings which had a sort of an active system in it, much more rigorous, much more complex system that comes in. But these sensors basically come in when we talk about level 2 and 3 of the fire alarm. If we go to the next picture, or next slide, This is an active and passive system. The active system has got motors on top and sometimes on the lower level of the building to help exhaust the gases that could be trapped in the pipes. The picture in the middle is a passive system that relies on the ambient temperature and ambient air to get rid of the smoke. You may find both of them in one building. I'd like Zeke for you to go through your experience with these systems in recent project that we went through.
Yes, David, thank you. This installation shows, this building shows two components. It is the same building, and those two pictures are taken from same area, but it's showing two different types of systems. The venting system, which is the middle picture on the left, it's a passive system. Now, the venting system on the right, it's an active system. And how do we know that it's an active system without knowing or going into the plans? Well, there is an enclosure right next to the termination of the vent. That is for a motor. So this is a motorized system that will exhaust any gases into the atmosphere. Before the motor is installed, an air test of the entire vent riser is performed, and that is prescripted or directed in the information bulletin and chapter 18.78. Specifically directs us to the plumbing code, and currently it is under section 712.3 for air test. So the methane venting system, once it comes out of the ground to a termination point, it must be tested under air pressure, 5 psi pressure for 15 minutes. So if it holds pressure, the system passes the inspection. Now it's important also to secure the venting system to the structure to comply with the city requirement, and the installation requires vertical supports and horizontal supports, and that's what you see. And just to refer you to the table, the city won't go any less than what is prescribed under table 3.3 of the California Plumbing Code. So after the testing and also checking that the termination of the vents are at least 10 feet away from any electrical equipment, air intakes, or any openings to the building, the inspection is approved. With this, I'd like to go back to the PowerPoint and have David conclude.
Yeah, this is also a picture of some sensors and active system with the signage necessary on the vertical risers. There's a lot of detailing involved, as we don't want to get into heavy duty details, but it's the work of professionals to put these systems together to make sure these buildings are safe, especially if it's an active system. And this picture is a good indicator of level of the expertise required just on the sensors alone in the vertical risers. Moving to the next slide, we want to wrap this presentation up. This was a successful project that was a refinery, now is converted to the big post office warehouse, I would say. but sign of city cleaning up, and people don't see the large petrochemical or chemical country. Next slide. This slide is a wrap-up slide. I want to know how many questions we have received so far. But in conclusion, building and safety is mostly in charge of the construction in the vicinity of oil wells and methane mitigation. In order to make life easier to practice in Long Beach, these pioneering ordinances were designed to make Long Beach more business friendly and safer environment for the city, for people to live in the city. When it comes to methane gas, the owners and developers, they have to start with hiring a professional engineer or professional testing company to measure the amount of the methane with existing on the site, evaluate the site mitigation plan based on this prescriptive system that city is offering or anything else they want, any other system they want to offer. They should put that on the plans, bring it in conjunction with the grading plans for permit approval and plan check. After the permit is issued, after the project is ready to go to construction, as Zeke said, there will be a pre-construction meeting, there will be inspection on membrane installer. The membrane installer has to be certified by the membrane manufacturer. So it's not the skill set that Zeke showed as far as spraying and developing that barrier. Not average or average contractors have it. There are specific subcontractors that are certified by the membrane manufacturers that they can perform that work, and we look for those credentials. Then city inspectors will observe smoke testing, so that has to be coordinated. So for us to be present there, so don't go smoke test your membrane barrier if or inspectors are not on the site. Explosion-proof electrical installation will require class 1 to class division 1 and 2 installation. Alarm system, sensors, involvement of fire department, building department, mechanical plan checkers have to be in the back of your mind when you submit a project to us. Final finale is the system certification. The certification comes from the qualified engineer to or inspection team before they can sign off a project. When a project is signed off, we still have to do the paperwork. The paperwork is that covenant that gets recorded, is pre-approved by the city attorney again. It's a separate document that comes in, it's independent from the oil well, but this document has a different verbiage in it and will get recorded on a property. And the purpose of it is, let's say 5 years down the line, 10 years down the line, the facility owners start digging the ground and do something and tamper the facility, all the work that's done, all bets are off. So that covenant on a title property tells the property owner, this is what you're buying, this is what you're dealing with, make sure that you do not deviate. At the same time, when the project developer is done, they provide an O&M for the building with the methane mitigation to the owner. And the owner is supposed to transfer it to the next owner. So this way, the history, the background of what happened, what kind of barrier was installed, where the pipes are, all that is transparent to the new owners, so we can keep the continuity of this methane protection in the buildings. With that, I would like to thank my colleagues who helped us with this presentation. As far as timing, we are right at 11:30. I'd like to stop at this point. You have our email to contact us, but we are going to be here in as long as needed to answer any questions that we receive either through the chat or through when we open this for public dialogue.
Yes, David, we have several questions now. The first one here is from Carlos Ovalle. Why did the city of Long Beach have a policy prior to this?
Good question. When the time is right and time is ready, normally cities move with certain direction in certain areas. It's always easy to say why we didn't have it. And since I've been in Long Beach for the last 8 years, give and take, we have been working on this topic off and on. But a lot comes into a city formally adopting a law for its public. So hopefully I answered the question.
All right. The next question is from Bojana Jaworski. Are the multifamily projects exempt if methane tests show no methane?
Yes, if they can show and prove, and their certified, qualified professional engineer sign and seal that there is no methane on the site, they can design the project with no methane mitigation.
All right. Next question is from Val Lerma. Is the requirement for methane mitigation independent of the well's compliance with current CalGEM abandonment standards?
Very good question. Extremely good question. The way the city perceives these two ordinances are independent of each other. That's why we have two ordinances, two different numbers, two bulletins. The developer has to comply with both, but one does not override the other. For instance, the covenant on one ordinance is completely different than the covenant on the other ordinance. The detailing of the projects are also different. The pipes that they take care of the oil wells gas are different set of pipes underground than the pipes that take care of methane. These are not combined systems. From an engineer standpoint, you know how engineers think. We decipher, we separate, and we address each issue at a time. So to answer Val's question, which is a very legit question, and I'm glad it's coming out at this end, these are separately inspected, separately reviewed, separate systems.
Okay, maybe you can comment. Val has an additional comment. It seems only dependent on the construction's proximity to methane zones, idle wells, hydrocarbon zones, and whether any of the three exemptions apply.
They are interrelated, Val, you're absolutely correct. But we can have a situation in Long Beach that there's a methane and there's no oil because of proximity to landfills. And vice versa, we can have a situation that there's no methane, but there's oil wells around. But then the testing proves certain things. So when we bring these projects in, we have to really, really utilize peer review when it comes to the oil wells. And if there's no oil well, our staff will have to deal with this and figure out what scenario this application falls into, so for us to be able to properly address. You ask a very good, very technical question, but we see each well like his own character with his own, or each site, its own characteristics. And sometimes they overlap the ordinances and sometimes they're independent.
And one more follow-up question from Val. What is the significance of the buffer radius around each well on the GIS map? It varies with well type, active, idle, etc.
You want to take that one, Jenna?
Sure. So the active well, it has a 300-foot buffer, and inactive wells have 100-foot buffer, and then for the landfill, which is a Swiss size, it has 1,000-foot buffer as well too. And any wells that are, or any area that is within the oil gas field that I showed you from CalGEM is also within the methane gas mitigation zone. Is there additional information that you wanted to?
Yeah, I will try. We also had to be reasonable and take the best recommendations that came from our consultants. According to the other cities and other agencies that they have developed their own methane zone, those numbers came about based on the research that we did. Obviously, the inactive well is more potential for methane, so we put a 300-foot circle around it. Idle well, or previously abandoned well, we put a 100-foot circle around it, just to get a starting point. But when you overlap all these circles, you will see that all of a sudden a whole zone became pink. And that's almost 40% of the city. So we were trying to be as conservative as it can be, but not over the top. So for instance, I work closely with Jenna to make sure properties that there's a sliver of the zone on them, we excluded those. Because it doesn't make sense if there is a 5% of a property fell into that circle, just that pink thing. So we have to do some give and take to come up with a logical boundary for the methane zone. I hope between two of us we answered your question.
We have a follow-up. Jenna, could you repeat the information about the buffer zones?
Like the footage? Sure.
Yeah, the footage.
So the active will be 300 foot, inactive is 100, and for the suicide, which is the landfill, is 1,000 foot.
We also considered the layers or areas that CalGEM identified, which we call a hydrocarbon zone. So that was also superimposed on what Jenna just said.
Maybe if I can add one more thing to that.
And,
This is Cheers.
Yes, sir.
The buffer requirement also are attempting to balance requirements from other stakeholders or other agencies. For example, in the active well scenario, we're also trying to accommodate requirements from the fire departments and their procedures for dealing with these type of wells. Others agency also include like requirements for methane areas from near other sources such as landfills. There is that buffer required by Cal Recycle for those type of facilities. So that's why you see that variable degree of buffers, and the city made significant attempts to try and make this as practical as possible while maintaining safety requirements from the various stakeholders that have interest in this type of developments.
Thank you for clarification, Jonas.
We have a follow-up question from Bojana Jaworski. Do all methane level classes have to comply with electrical hazardous classification?
Based on the table that we showed, if you're in level 1, regular electrical work. But if you are in level 2 and 3, then you have to use the Article 500 of the California Electrical Code. So level 1, no. Level 2 and 3, yes. Yes, sir.
Hi, I'd like to add that if any electrical conduit penetrates the membrane, it needs to comply also with the prescriptive seal-offs on the information bulletin.
This next question from Dave Shukla is to everyone, to all three. Could you please describe how the recent announcement by Governor Newsom of a 3,200-foot setbacks from oil gas operations may change the GIS data layers, including the wells active, cap layers, as well as data from pipeline routes, interconnection points, and sites of maintenance operations where venting or flaring of methane gas occurs?
Let me take what I know about that one. We just heard about that proposed rule. It's a proposal at this time, so it's nothing finalized yet by the state. And that regulation will be enforced by the state, not by the city. So at this time, what we have written for city ordinance of policy will not be impacted because the proposed law, when it becomes a law in 2023, will be enforceable by the state agency CalGEM, not City of Long Beach. So we are looking into it at this time on what comes up finally as a state law, and if all ordinances or all bulletins have to be upgraded, we will upgrade. But you're right, state is becoming more conservative on construction near oil wells. They're still providing means of providing special sensors to mitigate that requirement. That means more complexity to the jobs and more sensors and more separation distance from the active wells. That's Unless you guys, you want to share something from your background. Yeah, but that is something that we just learned from the city manager's office as late as last Friday.
A follow-up from Carlos Avalle on Dave Shuttler's question. How many wells are impacted by Governor Newsom's announcement?
I don't want to go on the record, and we don't know. To be honest, as much as we can. Yeah, that's a kind of really fresh out of a press type of question, and we are not ready to answer that question. We have not done our homework. The good thing is still a proposal.
We see no more questions here.
Excellent. We have some time. I'd like to open this forum to the rest of you guys who patiently sat down here and listened to 3 or 4 of us. First of all, I hope 3 of us with the mouth cover and glasses on, our voice was not muffled too much and you could hear all of us. But it would be very interesting to hear from your side of it what you heard from us. And hopefully it was worthwhile and rewarding. Anybody want to give us some input? We appreciate it. I hope we didn't bore you to death at this point. Yeah, it's a too long presentation, but sort of on time. I know it's about lunchtime. We promised everybody we'll finish this so everybody can attend the lunch and enjoy life a little bit. I'm still stuttering and waiting to hear from your side, but if you're shy and you don't want to tell us the truth, you can use my email and send us the information or questions or concerns that you have. From representing my panel here, any thoughts on your side?
Well, I just want to thank everyone that is in the audience for patiently going through this highlights of this just approved ordinance. And if any questions, David will probably be sending them to me, and I'll reply in a timely manner. And hopefully, if I can make a difference also during the inspections in the field.
Jenna, your last departing words?
Yeah, so thank you for joining. I hope you had a better understanding about the applications. Like Nick said, if you have any questions regarding on the GIS side, please email David, and I'm sure I'll get the question from him as well.
Yes, both of these individuals have been great comrades to get us to this point, and I have no doubts that I will rely on you guys and send you questions. Well, we are done at the end of this presentation, and I think we wish you a good day.